Hey everyone, it's Mrs. Brimlow, and in this video I'd like to review with you how to use this substitution method to solve a system of equations. So I'm not sure what page this is in the packet since I don't actually have the packet with me, but the page looks like this, solving systems. So you explored this a little bit after your graded check-in, so we're just going to review it together, go over any questions you might have, and do some practice together. Steps to solve systems by substitution. So the word substitution means to replace. So you're replacing something with its equivalent. Okay. So step one is to solve one of the equations for y equals if necessary. So you have to have one equation as y or x equals. Then you're going to substitute the value for y into the second equation. You're going to solve for the new equation to find x, and then you're going to substitute the value for x into one of the equations to solve for y. And then you want to check your answer by substituting x and y into both original equations to make sure it's true. So we know in a system of equations, a solution is where the two lines would intersect. It's a coordinate they have in common. So it would have to work for both equations algebraically to prove that it's a coordinate in each of those functions, a unique x and y value together. So I am going to be using a highlighter for this lesson. I really encourage you to have a highlighter, crayon, colored pencil, even just a different color that you can use to box. So it's really helpful when you are going to look at your substitution. Okay. All right. So we have y equals 3x, and then our second equation is x plus y equals negative 32. So in this equation, we do have a variable solved for itself, y. So they're saying the value of y in this first equation is 3x. So that means that in the second equation, y is going to be replaced with 3x. It's the same thing, okay? So when I do that, what you will find is that I have the same variable that I'm working with. So now I'm only working with x. I can't solve x and y at the same time. I have to do it one at a time, which is why we use substitution. So all we did was they tell us the value of y is 3 times x. Therefore, I can replace 3x or substitute 3x into my next equation where I see y because they're the same variable. So 4x equals negative 32. Divide by 4, and x equals negative 8. So I'm just going to write that up here. Now, I need to find y. A lot of people on Friday were writing 3x, which is true. That's what they tell us it is variable-wise, but I want just a number. So if y equals 3 times x, that means y equals 3 times negative 8, which is negative 24, okay? So the order pair point of intersection for this function, these two functions I should say, is negative 8, negative 24 if I was to graph it. So we substituted the value of y, which is 3x, into our equation. So we only were working with one variable, which we found was negative 8. So negative 8 is the x value of where these functions intersect. And then I took that and substituted it into my next equation so that way I could figure out what y was, because I have to have an x and y value if it has a point of intersection, which all of our problems today do. Okay. I'm going to skip number 2 and come back to it and take a look at number 3. So once again, using my highlighter, I have y equals. So I'm going to replace this expression right here with wherever I see y, which is here. So this whole thing, negative x plus 4, is going to replace y. Now, different from the first one that you should notice is that there is a coefficient in front of y, which means I'm going to multiply 6 by the expression. So when I rewrite this, it's going to look like this. So I use parentheses just to separate that expression for y. And if we look across, you can see we're only working with x now. It's the only variable we have, so we can solve this equation using what we know about equations. Now, with the 6 on the outside, I am going to have to multiply it, and in this case, distribute to each part. So this is 5x minus 6x plus 24 equals 13. And I can combine like terms. 5x minus 6x is negative 1x or negative x, plus 24 equals 13. I'm going to minus 24 from both sides to get x by itself. And that's negative 11. Now it's negative x. This is really saying negative 1 times x. The opposite of multiplying by a negative 1 is to divide. Therefore, x is 11. Okay, so 11 goes here. Now they tell me to find y. I'm going to do negative x, which is negative 11 plus 4, which is negative 7. So the ordered pair or point of intersection for these two functions is 11 minus 7. So each of these equations has two parts. Part 1 is or I guess you could say 3, really 3 main steps. Step 1 is to figure out what you're substituting and replace it in the following equation. Step 2, solve for whatever variable that is that you're left with. Step 3, take your answer and find the other variable. Okay, I'm saying it very generally, very broadly, breaking it down. It is a lot of steps. It's a lot of calculations you have to do. Please use a calculator if needed. There's nothing wrong with that. Make sure you're showing all your work. Later this week, you're going to have a graded task, and I'm going to be looking for you to show your work, and here's why. If you just say that the answer was, let's say, negative 8 and positive 24, I can't give you any credit. Even though you might have just missed a sign or something minor, I don't have the work to corroborate your answer. I don't know if you just looked it up or if you got it from someone else, or like I said, I don't know what you're thinking. So I really need you to make sure that you are copying down all your work for me to see, and so you can check yourself and see where your mistakes are. A lot of the time you're able to identify that when you go back, and with all the steps we have, it's very easy to get lost in them. Okay. All right, I want to do this last one together because a lot of people overthink this and make it trickier than it has to be. Okay, so this one, they're both y equals. So y is equal to this, but y is also equal to this. So y is equal to one thing and it's equal to another. So what does it mean about the two things? It means they're equal to each other. If it's easier for you, just look for whatever variable you have solved for first. Let's say the first thing we see is 9x minus 2 equals y. Then we're going to replace it with y in the next equation. So what that looks like is 9x minus 2 equals 3x plus 10. Okay. So what you're going to see is you're going to have variables on both sides of the equation, which we did way back in this year. Okay. And it's just the same as solving the equation normally, except the one extra step is getting the variables on one side as well. So 9x and 3x. I always like to move the term with the smaller coefficient. So we're going to eliminate and get rid of 3x on this side, okay? And what we do to one side, we do to the other. So I'm left with 6x minus 2 equals 10, okay? So that means there's no more x's on this side. They're all together on this side, okay? And we kept our equation balanced. Now I just have a two-step, so I'm going to add 2 to both sides. 6x equals 12 divided by 6, x equals 2, okay? Now, we can use either equation here because they're both y equals. I'm just going to use the first one. So y equals 9 times x, which is 2, minus 2. So that's 18 minus 2, which is 16. So the point of intersection is at 216 if I was to graph this. That's the point they have in common. And to check your work, you take your, I'm just going to set it up, but you should be able to do this since we did practice this for our last assessment. So you would write each of the original equations, take what you think the answer is, and substitute it in, and then check algebraically that it is the solution. And these would all check out, so it would work. Okay. All right, so today's practice, look through Canvas to see what you should do. If you have any questions, please reach